Hi, my name is Sebastian, and I welcome you to today's workshop with the somewhat long title, NEURO SWING System Ankle Joint, Functional Adjustment Possibilities for Individual Optimization of an Orthotic Fitting. This sounds complex, and it is, but I can tell you. We will have a guest today. She is Milena, who will help me explain the optimization of the orthotic fitting live with her case. Have fun! In this video, we will talk about the adjustment possibilities of the NEURO SWING joints. This procedure always follows the same method and can therefore be reproduced in this sequence. Statically on the workbench, bench alignment, statically on the patient, static alignment, and dynamically on the patient, dynamic alignment. I would like to demonstrate these points with the case of Milena. But before we get into the actual topic, I will briefly show you an overview of the NEURO SWING joints family. The NEURO SWING joint is available in 5 system widths, 10, 12, 14, 16, and 20 millimeters. In the 3 different profiles, straight, bent inwards, and bent outwards. To expand the line of the modular ankle joints, we have introduced the plug-and-go series, which can be easily exchanged on the finished orthosis. The joint function can be adapted to the individual needs of the user even after the orthosis has been completed. The NeuroVario 2, NeuroVario Classic, NEURO SWING, NEURO SWING 2, NeuroVario Swing are available. The NEURO SWING H2O is available as a waterproof version in the sizes 12, 14, 16, and 20 millimeters. The NEURO SWING H2O, just as the NEURO SWING, has dynamic and adjustable dorsiflexion and plantar flexion stops. In addition to the optimal adjustability of the static alignment, 5 spring units of different strengths are available to adjust the required spring force. In the NEURO SWING and the NEURO SWING 2, the range of motion can be additionally limited. The settings on the system ankle joint do not influence each other and are therefore independently adjustable. The selection of the spring units for the initial setup is taken from the configuration results. This is generally a good starting point for the static alignment on the patient. Let's start with checking the bench alignment. The plumb line should fall from the mid-AP measurement at the knee level down to the front half of the support surface as shown in the picture A. The supporting surface extends from the highest point of the roll-off area to the rear edge of the heel. Checking the static alignment on the patient. Understanding standing is what we call this part of the static alignment. Regardless of movement restrictions, misalignments, and other compensatory features, the patient's ability to stand can be evaluated as follows. If the plumb line falls from the center of the body on the green or yellow marked area as shown under A, the patient is able to stand and to use the available base of support optimally for biped standing. The patient is able to stand freely and uses, if at all, mobility aids only for additional support and balance. If the plumb line from the center of the body falls outside this area, as shown in B, the patient would fall over without an additional mobility aid. This means the support area would be increased as marked here in red with the help of the arms. There would be a need to lean or support in order to increase the supporting surface available to the patient. So we no longer speak about biped standing, and the orthosis has missed its intended purpose. The first dynamic function test is made in a standing position. We simulate the load of the mid-stance phase. What we are doing is checking if the anterior spring unit is strong enough to provide adequate safety. If it is not strong enough, we would see that the knee angle has changed during this gait phase, as shown in B. With this simple test, you can choose the right spring unit in at least 80% of the cases right away. If this test was successful, the patient may now take the first steps. Always observe a series of steps and consider the situation carefully before acting. Is there an initial heel contact? If not, the selection of the rear spring unit could be the cause. But let's look a little further. Do we see an almost physiological loading response? The forefoot lowers in a controlled manner and the knee angle remains slightly flexed under load, as shown in A. If the posterior spring is too strong, the patient will experience a flexion moment and the tibia will be accelerated forward, as seen under B. If it is too weak, the forefoot slaps without control and the patient may fall into hyperextension, as shown in C. What do we observe in the gait phases late mid-stance to terminal stance? A slight dorsiflexion in late mid-stance and a timely heel off in terminal stance, as shown under A, indicate that the spring has been optimally selected. On the one hand, it is dynamic enough to enable a physiological dorsiflexion, and on the other hand, it is strong enough to activate the forefoot lever. But if we observe a dorsiflexion in late mid-stance and the heel remains on the ground in terminal stance, then the front spring unit is not strong enough. Hold on, you won't get away so quickly. Those were 7 minutes of tough biomechanical know-how. That was way too fast to really understand what it's all about. It took me years to understand it myself, and yes, knowing how we orthotists actually are, I think a practical example could be helpful. We have to see how a patient walks before, how he walks afterwards, and which screws we have to turn to achieve such results. This is exactly what we will look at in detail with Milena. Hello, I am Milena. I study orthobionic in Göttingen and have a hereditary spastic paraplegia or dystonia. 2 years ago, during my studies, I came to the conclusion that I could possibly benefit from lower limb orthosis, and how this has been a profit to me, you will see now. I will take care of the static alignment of the orthosis while Sebastian explains what is going on. Yes, we have made a mark on the orthosis. We have marked the middle of the AP measurement at the knee level with this small dot, and from there we will drop the plumb line down and adjust the orthosis so that the line falls on the front half of the supporting surface. Ideally, this alignment of the orthosis will match the basic setting of the joint, which we can determine by looking at the small scale that has been engraved on the stirrup. Milena is now screwing the spring unit so far so that it is not compressed, but just enough so the top section can move without restrictions from front to back. This corresponds to the correct basic setting according to the scale. And now we only need to check how the plumb line falls. We drop it from the top, from the mid-AP measurement at the knee, and check that it falls into the front half of the supporting surface. Remember that the supporting surface starts at the highest point of the roll-off area and ends at the rear edge of the heel. To check the static alignment on the patient, I dimmed the light so you can clearly recognize the laser line that is showing the line that falls from the center of mass through the middle of the AP measurement and down to the front half of the supporting surface. We now observe the position at mid-stance. This way, we prove if the anterior spring provides enough stability for Milena. Always observe a series of steps and check whether the initial contact is done with the heel. Ideally, the forefoot goes down at loading response in a controlled manner and the knee angle remains in a slight flexion during the load transfer. In an optimal situation, the anterior spring unit is dynamic enough to allow for a slight dorsiflexion in late mid-stance, but also strong enough to ensure that the heel is clearly elevated from the ground at terminal stance. Once more, for comparison, Milena is walking without an orthosis. Here we see Milena in the frontal plane with orthosis. And one last time for comparison without orthosis from the front. Many thanks to Milena for being with us today and helping us make this workshop more vivid and clear. I hope you enjoyed it and that you have some interesting information to take home. Exactly. And if you liked the video, let us see that thumb up. Bye. See you next time.